Hi guys, welcome back to NerdNarrative. If you haven't watched part 1 yet, join Subqueries and CTEs. Link is in the description. Go watch that first. Today is the part 2 of SQL. We are covering two things. Number 1, window functions. In window functions, row number, rank, dense rank, lead, lag, and partition by. Number 2, query optimization. How to write SQL that actually performs well in real work. Same employee table, same data, let's go. Same EMP and department tables from part 1, run this first to set up our data. 5 employees, salaries ranging from 50k to 80k. Keep this in mind. Every window function result comes from this data. Before we write queries, what exactly is window function? Normal aggregate function like sum or average collapse all rows into one result. Window functions do something different. They perform calculations across rows, but keep every row in the result. Okay, think of it like a sliding window moving over your data. Each row gets its own calculated value. That's why they are called window functions. First, row number assigns a unique number to each row. Most commonly used for ranking and pagination. Sneha gets row number 1, highest salary. Ravi gets row number 5, lowest salary. Now row number always gives unique numbers. Even if two employees have the same salary and they get different row numbers. Row number assigns a unique sequential number to each row. Use it for ranking, finding top and records for pagination. Now rank and dense rank. These are where it gets interesting. Let me add a duplicate salary first, so you can see the difference clearly. Look at Priya and Rahul. Both have salary 70k. Row number gives them 2 and 3, always unique. Rank gives both of them rank 2. But then skips rank 3, next person gets rank 4. Dense rank also gives both rank 2 but does not skip. Next person gets rank 3. And that's the only difference between rank and dense rank. Whether it skips a number after a tie, rank skips number after a try. Dense rank never skips, consecutive always. Now partition by. This is what makes window functions really powerful. Partition by divides your data into groups and applies the window function within each group. Example, rank employees within their own department. See how the rank resets for each department. IT department, Priya is in rank 1, where Arjun is rank 2. Finance department, Sneha is rank 1. Without partition by, ranking is across all employees. With partition by, ranking is within each department. And interview question would look like, what does partition by do in the window function? Partition by divides data into groups. The window function runs independently within each group, like group by, but keeps all rows in the result. Now lead and lag. These access values from other rows without using a join or subquery. Lag looks at the previous row. Lead will looks at the next row. Real use case would look like a salary comparison with previous employees. Lag gives you the previous row's salary. Lead gives you the next row's salary. Different priv shows how much each employee earns compared to the person above them in the ranking. First row has null for lag, no previous row. Last row has null for lead, no next row. Interview question. What is the difference between lead and lag? Lag accesses value from previous row. Lead accesses value from the next row. Both used for trend analysis and comparison queries. Now, query optimization. This is what separates good analysts from great ones in real work. Writing SQL that works is one thing. Writing SQL that performs fast is another. Let's go through the most important tips. First thing, avoiding select star, which is bad. Fetches all columns even if you need only 2. Where good one is fetching only what you need. That is giving a particular column name. Select star will fetch every column from the table. In real database with 50 or 100 columns, that's huge amount of unnecessary data. Always specify exactly which column you need. Why should you avoid select star in production? It fetches unnecessary columns, right? So wastes memory and slow query. Also breaks code if table structure changes. Now, filter your data as early as possible. Reduce the number of rows before joining. Less rows to join, faster query. How do you optimize a slow join query? Filter rows before joining using where or subquery. Reduces data volume before the expensive join operation. Indexes. Indexes are one of the most powerful optimization tools. Okay, think of it like a book index. Instead of reading every page, you jump directly to what you need. Right? Without index, SQL scans every single row. With index, SQL jumps directly to matching row. In tables with millions of rows, this makes a massive difference. Interview question would be like, what is an index in SQL and when do you use it? Index speeds up data retrieval by avoiding full table scans. Create indexes on columns used frequently in where and join. So too many indexes can slow down insert and update operation. Last tip, the explain keyword. This is how real SQL developers debug slow queries. Explain. Shows you the query execution plan. It tells you how many rows SQL is scanning, whether it's using an index or not, and where the bottleneck is. In real work, whenever a query is slow, first thing you do is run explain. Interview question would look like, how do you debug a slow SQL query? Run explain before the query. Check the type of the column. All means full table scan. Batch check the key column. Null means no index used. Optimize. So that's everything for part 2. We covered row number, rank, dense rank, lead, lag, and partition by. And query optimization, avoid select star, filter early, indexes, and explain. Now it's your turn. Answer the questions displayed on the screen and drop your answers in the comment section. I'll reply to each and every one. All resources, queries, interview questions and answers, PDFs, everything is available in the description. And if this video helped you, subscribe. Next video is Python deep dive covering NumPy, pandas and data visualization coming next week. See you there. Bye bye.